All right, so we're talking about Chapter 6, Section 2 today. So we're still solving systems of equations, but this is kind of more of an applicable version of doing that because you don't necessarily need to graph them. I prefer this method. I think you guys probably will too because graphing can be a pain in the butt sometimes. And it doesn't always work. Like you saw, occasionally we had to type it into the calculator, try and figure out where. So this method will always work, okay? And it doesn't matter if decimals or fractions or anything like that is involved. So when you solve by substitution, what you need to do is, if it's necessary, sometimes it will be necessary, solve at least one equation for one variable. So that means solve it for either x or for y. Okay, either option. Solve it for x or solve it for y. All right. Once you do that, solve for the one variable, because if you replace, you'll replace it. So if you solve for y, you'll replace y with its new equation in terms of x, or vice versa. Substitute in the value that you got from step 2, and you will find the other value in step 3. So what that looks like is, if you look at example 1, step 1's already taken care of because y is equal to something. That means y is alone, y is already solved for, so we don't need to solve for a variable. There's one that's already solved for. But what I can do is y is equal to this, and y is in this equation. So take what y is equal to and plug it in. So I can take 3x plus 2x plus 1 because that's what y is equal to. So I'm replacing y with what I know y is equal to. This goes in for that. And then I set it equal to -9, and I'm going to solve. These parentheses are not actually needed. They were just there to show you that I was plugging in for the one variable of 9, or for y. So now I'm going to just start solving. And get your like terms together. 3x plus 2x is 5x, plus 1 is equal to -9. Solve for this, subtract 1, 5x is equal to -10. Divide both sides by 5, and you'll get that x is equal to -2. All right, so for this system of equations, you know it's a one solution because you got an x value. Okay, then if you plug in your x value up here, you can find y. 2 times -2 is -4, plus 1, so y is equal to -3. So then your point is, you have one solution and your point is at -2, 3. Okay, so take a pause and try 1A and 1B. Okay, so for 1A, you would plug in the 4x minus 6 for y, so you'll end up with 5x plus 3 times in parentheses, because all of that is going in for just y. So it's times 4x minus 6 is equal to 1. So when you do that, you have to distribute your 3 in, and that'll become 12x minus 18. Get your x's together, subtract or add over 18, and then divide by 17, and you'll get x is equal to 1. Take your 1 and you plug it back into your top equation, and you'll get y is equal to -2, and then so you have 1 point, you have an x value and a y value. So there's your answer. 1 is equal to -2, or x is equal to 1 and y is equal to -2, and you plug them into a coordinate pair. Okay. Same over here with 1b. Becomes 2x plus 5 times the quantity, because that quantity is what y is equal to. So times the quantity of 3x plus 10 becomes 2x plus 15x plus 50 is equal to -1. So 17x plus 50 is equal to negative 1. You subtract over your 50 and then divide by 17 and you'll get x is equal to negative 3. Then you take your negative 3 and you plug it back in up here for 3x plus 10 and you'll get that y is equal to 1. So then you have one solution because you have a coordinate pair and your solution is at negative 3, 1. Okay? If you go down to example 2, we're going to solve by substitution. The only difference is you don't have one that's already solved for y, so you're going to have to do that. You can either solve for y or you can solve for x. It doesn't really matter which one you want to solve for, but I'm going to do this first one. And I have x plus 2y is equal to 6. All right? You can solve for y or you could solve for x. I'm going to solve for x just because it's a little bit easier. So I'm going to divide both sides or subtract 2y from both sides. And that'll give me x is equal to negative 2y plus 6. Okay? So, like I said, it doesn't matter that we solved for x this time. But now that we have x, we're going to take this and it's going to get plugged in for x. So I'm just substituting it in. That's why it's called the substitution method. 2y plus 6 minus 4y equals 28. All right. So I substituted in what my x is equal to, which put everything in terms of y. So now I have one variable and I can solve. So I'm going to distribute in my 3. So negative 6y plus 3 times 6 is 18 minus 4y is equal to 28. Then I'm going to take negative 6 and negative 4 and combine those, and that'll give me negative 10y plus 18 equals 28. Subtract your 18. Negative 10y is equal to 10. Divide by negative 10. And y is equal to negative 1. Take your negative 1 and plug it in. You can plug it in right there. So x is equal to 2 times negative 1 plus 6. X is equal to negative 2 plus 6, which is 4. So we have an x value and we have a y value, so that means we have one solution. And it's at 4, negative 1. Because 4 is our x, so it goes in for x. Negative 1 was our y, it goes in for y. So again, go ahead and pause the video and try 2a and 2b. Alright, so for 2a, I solved here for y. So I added 3x to both sides, and that left me with y is equal to 3x minus 13. So the 3x minus 13 went in for y, and that left me with 4x plus 5 times the quantity of 3x minus 13 equals 11. You distribute your 5, combine your x's, and you'll get 19x minus 65 is equal to 11. Add your 65, and then divide by 19, and you should get x is 4. Then I take that 4, and I plug it back in right here to get 3 times 4 minus 13, which would be negative 1. So here is my solution. 4, negative 1 would be the point where these two lines would intersect. All right, same thing over here with 2b. I solved this one for x just because that was the easiest one to solve for me, so I added 3y to both sides. All right, and that left me then with this going in for x. So I got 5 times 3y minus 9 minus 2y is equal to 7. And then you would distribute your 5 and combine your like terms. So you're left with 13y minus 45 is equal to 7. add your 45 and divide by 13, and again you'll get y is equal to 4. So then you take your 4 and you plug it in over here to solve for x. So 3 times 4 minus 9 gives you 3. So your x value was 3, your y value was 4, and your coordinate pair is the pair 3, 4. And that's your answer. Now if you look at example 3, we haven't forgotten about the options where we have no solution or infinite solution. Those will still happen, and you can still tell when those happen when you're solving for these using substitution, okay? And we'll show you how. So if you get y is equal to 2x minus 3, it's already solved for y, so I'm just going to take that in, and I'm going to plug it in and substitute and solve, just like I was before, okay? So I'm going to get negative 6x plus 3 times 2x minus 4, which is equal to negative 12. Distribute, get negative 6x plus 3 times 2 is 6x. 3 times negative 4 is negative 12. It's equal to negative 12. Combine your like terms. Negative 6x plus 6x. That's 0. Negative 6 plus 6 would be just 0x minus 12. Negative 12. That goes away. We don't need to write that. So it's just negative 12 equals negative 12. That means it doesn't matter what x and y value we plug in, we're going to get a true solution. So this is a true statement, so it's infinite solutions because that is true. All right, so try 3a and 3b and see what you get. Okay, for 3a, you would plug in this here. I plugged it in for y. When you do that, be careful because you have to distribute that negative sign in. So there is a negative 1 hiding there that needs to be distributed in. So it becomes negative 2x, or 2x minus 2x plus 3, which will leave you with the 2x and the negative 2x going away, and that just leaves you with 3 is equal to 8. Well, 3 is not equal to 8. That's a false statement, so you have no solution there. Over here, we would plug in, first I solved this top one here for y. So I subtracted over 4x, which gave me negative 3y is equal to negative 4x plus 1, divided both sides by negative 3, and that gave me 4/3 x minus 1/3, okay? I plugged all this in for y, which gave me 6 times 4/3 x minus 1/3 minus 8x equals negative 2. Distributed in my 6, which gave me 8x minus 2 minus 8x equals negative 2. My 8x and my negative 8x, they went to 0x, and then negative 2 is equal to negative 2, so I have infinite solutions there. If we look at the last one, we have a real world problem. These are where this type of problem is going to be most beneficial, this method, because you don't have to guesstimate, you don't have to try and type it into your calculator and figure out where they meet and slide things all around. You can just solve it, and if you get a decimal, cool, you got a decimal, but you know what it is because you solved it algebraically, not on a graph. All right. So it says a store sold 125 car stereo systems and speakers in 1 week. The stereo systems sold for $104.95. And then the speakers sold for $18.95. This is for the stereo. This is for the speakers. The sales from these two items came to a total of $6,926.75. How many of each item were sold? Okay, so they gave us our table over here. We're going to use this table to start solving. Okay, so everything I just wrote there is actually over here in the table. So we have our number of stereos sold. Okay, they called those C. Okay, so this is our stereos and these are our speakers. So if I take the number of stereos plus the number of speakers, I need to get 125 because that's how many of those I sold. Okay? I don't know how many speakers or how many stereos they sold, but I know total they made 125. I also know that if I take the price of my stereos plus the price of my speakers, I need to end up with $6,926.75. Okay, so this is how much I spent. Oh, this is how much I made. This is talking about money. These are just talking about the number of systems of each one. Okay, and again, here, these are my this is my stereo, and this is my speakers. All right, so I'm gonna solve this one for a variable because it seems a lot easier. So I'm going to subtract over t, and that'll leave me with c is equal to negative t plus 125. I'm going to take that and plug it in here. So I'm going to have 104.95 times negative t plus 125 plus 1895 t equals 6,926.75. Okay, I'm going to solve this. 104.95 times negative t is just negative 104.95 t plus 104.95 times 125, which gives me 1311875. Plus I still have the 1895t equals $6,926.75. Okay, I'm gonna do this. Okay, so that was just setting up the problem. Now I'm solving it. I know there's a lot of numbers going on here, but it's manageable. So now I have negative 104.95, and I need to combine it with my other t variable, which is 1895. And those two together add up to negative 86t plus 1311875. Now subtract your 13,118 from both sides. So and you get 6,000, so negative 86t is going to equal negative 6,192. Divide by negative 86, divide by negative 86, and you'll get that t is equal to 72. Okay, so that means they sold 72 speakers. To find out how many stereos were sold, plug in 72 here. Okay, so C is equal to negative T, so negative 72, plus 125, which is 53. So I sold 72 speakers and 53 stereos. Okay? And that would be the problem. That's how you would solve that. So I know there's a lot of decimals going on, but the process didn't change the entire time. All right? So I want you to go try page 351, 9 through 23. Odds for homework.